Good morning. Good morning to all attending. It is my pleasure really to welcome everybody to this webinar that is called Digital Tools as Enablers of More Efficient Energy Consumption and Industrial Waste Heat and Cold Recovery. My name is Mafalda Silva. I am a principal researcher at INEGI. INEGI is an RTO based in Portugal that looks at innovation in industrial and mechanical engineering. I am also the coordinator of EMBERS project. EMBERS is part of the Alliance4ECEI that is organizing this event, and it will be presented later on this morning. A short presentation on the Alliance. The Alliance4ECEI stands for Alliance for Energy Cooperation in European Industries. The collaboration didn't begin too long ago, so back in 2020. And it became a little bit more consolidated in April 2021. This was with the signature of a collaboration agreement. The Alliance4ECEI, it's an initiative that was originally founded by 5 European projects working on waste heat recovery and industrial energy cooperation. So the ones that you see circled in pink in this picture. So the founding projects were EMBERS, INCUBIS, RAC, SoWHat, and SPARKS. Later, SPARKS concluded, and this has been replaced by CORALIS. Then, more recently, the Alliance has also been joined by 2 additional projects that joined as collaborators. The ones that you see circled in blue in this image, Bamboo and WEDistrict. So this webinar is jointly organized by the board members and the collaborators of Alliance4ECEI. And it aims at exploring the current status regarding waste heat and cold technologies and challenges, as well as how digitalization can contribute to overcoming these challenges that were identified and bringing useful software tools to the market. So very quickly, again, this webinar is organized by the board members and the collaborators of the Alliance, and it looks at exploring the current status regarding waste heat and cold technologies and challenges, as well as how digital tools can contribute to overcoming the challenges identified. So in specific, a number of projects have been developing some tools, and these will be presented later today. For example, these tools can somehow support industries in improving their energy efficiency, for example, by matching waste heat supply and demand. Also important to mention that the Alliance is open to external entities that may be interested in joining, so feel free to get back to us should you be interested in this work. So very quickly, the objectives of the Alliance are to enhance the collaboration to boost energy efficiency in European industries, to maximize the impact and improve the quality and the relevance of the outputs generated by each of the projects within the Alliance, to boost industrial symbiosis as well as waste heat and waste cold recovery and reuse, and to contribute to the 2050 goal of net zero carbon emissions. So for today, this event will, again, as mentioned, will address the current challenges regarding waste heat recovery and reuse. And then it would look at the different solutions or proposals of solutions that the projects within the Alliance are developing. Then we will have a roundtable discussion that it's bringing together different stakeholders along the value chain. And the roundtable will analyze how digital tools can support cleaner energy transitions in industry, and this will be moderated by our guest moderator, Oksana Krasatsenka. Let me conclude. I hope that you find it interesting, and there will be some room for interaction at the end. So there will be a Q&A session. You are welcome to write on the chat any questions that you may have, and those will be either addressed in real time or compiled at the end for the Q&A session. Also at the end, if there are any pressing questions or comments that you would like to bring, you are welcome to raise your hand and we will try to give the floor to you and give you permission to speak. So as mentioned, feel free to get in touch if you're interested. The contact is on the screen. And so without any further ado, let me give the floor to Asier Zubero, Asier is a climate change manager at CIDENOR and project manager of CORALIS. So, Asier, the floor is yours.
Okay, thank you. Thank you very much. Let me share first with the camera. So can you see my screen?
Yes, we can see.
No.
Okay. So first of all, thank you for this opportunity to share with you the CORALIS project in CNR. First of all, a brief introduction of what is CNR. CNR is a special steel making company. We are located in Spain. Our annual sales around 700,000 tons per year, and 1,800 employees, all of them in Spain. Regarding the business units, we have the main facility in Basauri with the melt shop with a capacity around 800,000 tons per year. And then we have rolling mills in Basauri as well, in Azkoitia, in Reynosa, and in Vitoria, and also a couple of small facilities in Poliña and Legutiano with some other processes. And regarding the products we produce mainly hot rolled bars, semi-product like billets or round billets, and wire rod. And our main market is the automotive industry with around 75% of our production, and then some other applications like energy, some equipments, oil and gas, or railway. And as I said, our production facilities, the main facilities in Basauri with the melt shop, and we feed the rest of the rolling mills in Basauri, Vitoria, Azkoitia, and Reynosa with the steel produced in Basauri. So let's go with the CORALIS project. The main task in CNR with the CORALIS project is to make an assessment of economical assessment of the thermal energy storage system in CNR through a recovery waste heat for steam generation, and of course a potential dispatching to some other industries around CNR. So first of all, this is the analysis of the energy map in CNR. As a steel company, the energy consumption is very high, not only electrical but also natural gas. So in blue, you can see the main electrical consumptions, with the main one, of course, the electrical furnace with almost 50% of the total electrical consumption of CNR. And in yellow, you can see the natural gas consumption. So as we have a very big consumption of electric energy and natural gas, we also have very big heat sources. You can see in like orange marks the main heat sources to analyze for this project. So the main one, of course, is the electrical furnace. Then we have the reheating furnace for the rolling mill, and the heat treatment furnaces as a heat source. So the first step we did is to analyze the waste heat in order to recover this heat. So this first of all, we have the EAF furnace. This one is a discontinuous waste heat, as the process is not constant. When we start the process, the waste heat goes up to 1,000 degrees. but we after 1 hour when we finalize the process, it's around 200, so it's not a continuous heat. And the system integration is really complex. Then we have the reheating furnace. This is continuous process, and the temperature is always from 300 to 400 degrees. And in reality, it's a simple integration because the reheating furnace is like a big box, and the integration of the recovery, waste recovery is quite simple. And then we have the heat treatment furnaces. It's almost the same as the reheating furnace, but the problem is that we do not have 100% of our production through heat treatments. So it's not a continuous process. So the best waste heat point in order to recover the heat is the reheating furnace. But the problem is how can we match the waste heat with the demand of heat? And that's the main problem in a lot of waste heat recovery projects. And that's why we selected, we have this technology partner, which is Energy Nest. They developed the thermal energy storage, and this solution help us to match the waste with the demand. So this is the process that we are analyzing in CORALIS. First, we have the waste recovery unit in the reheating furnace. Then we have the thermal battery as a backup of this waste heat. And then we have two possibilities. First of all, of course, is to use part of this waste heat in our process. And then the rest of the heat not used in CNR, we are analyzing to send to some other industries or district heating. So the analysis we did of this waste heat, we can recover up to 45 gigawatts hour per year. This is a huge heat that we can recover from our process. And as the main important point is to analyze where we can use this heat, and as the best option, we analyzed the vacuum process, where we can use around 30 gigawatts hour per year, which could avoid up to 8,000 tons of CO2 per year. So we have an extra around 15 gigawatts per year that we can send to external industries or district heating. And we are analyzing now these different options. Unfortunately, CNR is not located in an industrial area, so we do not have a lot of industry around. But luckily, we have a very active local government with district heating, so we are analyzing this district heating analysis. So the main challenges we have is the imbalance between generation and demand, as I said, not only internal but also external with other industries, and that's why thermal batteries are very important for this matching between demand and generation. Other challenge is the high investment of the equipments. We have to make a big investment in the recovery, waste heat recovery, then the thermal batteries, and then the use of this heat. So we need a big support from governments in order to achieve these big investments. Then regarding the industrial symbiosis, there is a lack of cross-sector cluster that could work or help as a catalyst for industrial symbiosis. because, for example, in the steel industry, you have a cluster of steel industry where we share different projects, but there is no a big cluster that put in contact with some other industries in order to analyze these kind of projects. And the last one, regarding the district heating, the local authorities are very important in this kind of projects because also the investment is very high, not only internal investment in the industry, but also a big investment in the district heating. So it's very important the support of these local authorities in order to achieve this district heating. And well, that's all from my part. You have here my email, and if you have any doubt, you can contact me.
Thank you, Asier, for your presentation.
Okay. Okay, now. Okay, thank you. Thank you very much.
We have a question in the chat. I would say we keep it for the Q&A session at the end of this webinar. As it is stated in the in our agenda, we are proposing some questions, like a quick poll, to get an overview on the current situation for the energy use of industries. The poll should start immediately, and we have prepared 2 questions. So the first question should now appear as a pop-up window to your screen. And our first question would be, are you aware of the energy that your neighboring industry or services produce? So you can have 4 answers. Yes, for sure. No. Do they produce any? Maybe, perhaps I can find out. Or you can say, never thought about it. We'll give it a couple of seconds. Once you have answered the poll, the result is immediately shown in the poll section, or if in case, since we set it up here in Germany, unfortunately, we have only the Umfragen point, so you can directly go to this app and then see the replies that were given. So far, we have received 34 answers, and this will give us a good also idea on what we will discuss later on in the panel discussion. So from the percentages now, I see that like only 4% know what the neighboring industry or services are producing, and the large majority, almost 50%, says maybe perhaps I can find out. So these are the 2 deviating answers to our first question. Then we come to our second question, which is shortly introduced to the poll. So our second question is, are you aware of the energy sources they use? So you can either say, yes, only fossils, yes, a combination of everything that is available, or yes, mainly renewables-based energy, or again, no, never thought about it before. Looking forward to your replies. So far we received also 25 answers to our second question. And here it's very good to see that those who know what it's used know that it's a combination of everything that's available with over 50%. And on the other hand, we see also in the other way, yes, mainly renewables-based energy is like down to 4%. So at that point, I would like to close the poll. Thanks a lot for your replies, and we keep the results in mind and maybe come up with some additional questions to you or answers in our panel discussion after the next presentation. Thanks for the question on the polls. We will also see how we tackle that in the Q&A session.
So I think we can proceed with the second presentation, which should be mine. So good morning, everyone. I'm Serena Scotton. I work as project manager at Rina Consulting, and today I will present you several projects, that are developing tools for waste heat management, and they are participating in the Alliance4ECEI partnership. This is an overview of the 5 projects that I will briefly present to you in my presentation. Let's get started with this SoWHat project. So this is a European funded project which is coordinated by Rina Consulting. The main objective of this SoWHat project is to develop and demonstrate a market-ready integrated software which will support the industries and the energy utilities in selecting, simulating, and comparing alternative waste heat and waste cold technologies. And also the goal is to include renewable energy sources in the system, so that's to integrate for the renewable energy sources. Within the tool developed in SoWHat, we aim at simulating how to balance the local forecasted heating cooling demand and supply. As you can see, so the project is already quite mature and it will officially end in November 2022. So we are now, let's say, preparing and publishing the final results about the project. Everything that is developed in SoWHat, especially the tool, will be validated in 11 different type of industries. And as you can see here from the this overview and table in gray, the tool will be validated in 11 industries located in different European areas and also in different sectors, going from food and beverage to chemical, steel, and paper and pulp industries. So we will really benefit from feedback from relevant industries coming from different sectors. Then a quick overview on how the SoWHat tool is composed. So I have to highlight that the tool has two functions. One is the online free version that is available, and the second one is the more advanced tool, which is commercialized. And here from this slide, you can have an overview. So the, let's say, the aspects that are available only in the online free version are marked with the red star, while the tools and settings that are available in the more advanced commercial version are marked with the blue star. As you can see, of course, the more advanced tool has more components and more aspects. But just to give you an insight on the overall tool, so both two functions, online and commercial version, are composed by three workflows that are first the baseline on the waste heat and cooling. So as you can see from here, it aims at collecting data via energy asset audit portal, and also to collect data on the industrial energy flow or heat and power supply baseline, etc. Then there is the simulation of technologies and scenario, where different and multiple methodology and modeling are produced. And then there is the final stage with the reporting and decision support. In here, as you can see, different KPIs and comparing scenarios and business models are produced and shared, let's say, with the user. This slide quickly presents the layout of the tool. In here we have the images and on how the tool works. In here we use one case study presented in the SoWHat project, which is the Martini Rossi industry. And yeah, this is just to give you a sense on the layout and how the tool works with the reports that are downloadable. Then moving to another project that is involved in the Alliance, we have the RACES project. The RACES project is supporting industrial parks to becoming ecoregions and aims at implement energy cooperation. To do so, within this project, they are delivering 3 different tools. The first one is the self-assessment tool, which aims at facilitating the process of exploring opportunities for energy exchange, such as requiring data on the energy supply, energy demand, or information on stakeholders. Moreover, data inventory is also provided as to facilitate users in finding this information. Then they are delivering a legal decision supporting tool, which aims at lower the legal barrier and help develop energy cooperation. And then there is the third and last platform developed within the project, which is the energy management platform, which is a key to running, settling, and optimizing the energy exchanges between companies. So the RACES project, of course, as mentioned, put the energy cooperation as a fundamental solution. It also put the industrial sites and business park at the center of the energy transition, and they can cover a key role for the energy transition in Europe. And circular economy model-based are also key for heat exchange and industrial symbiosis. Then going to the third project, this is the Bamboo project. The Bamboo project aims at boosting the industrial flexibilities and therefore to support the heavy and intensive industries, for instance, in the steel, petrochemical, minerals, and pulp and paper sectors to become more sustainable. And also, so therefore, to abandon the fossil fuels and access to new technologies and also flexibility on the electricity supply. As we can see from the slide, the Bamboo project is based mainly on three innovation pillars, which are the electrical flexibility, waste stream valorization, and waste heat recovery. And indeed, these three pillars are supporting the intensive industries to adapt to industrial demand response schemes. Here we can see an overview of the tool for the techno-economical viability analysis of the ORC technology developed within the Bamboo project. In here, so we have, let's say, 4 pictures of the tool. So on the first stage, the tool will ask the user to insert data or upload data through Excel or CVS format. Data about the heat source stream or cold source stream. Once the data are uploaded, it appears a tab with the visualization of the inputted data. Then this data is analyzed, and there is a tab for visualizing the output data. In here, I try to zoom a little bit so you can have a better view also of the image in the slide. In here, as you can see, there is a graph indicating what is the generated electricity, the consumed electricity, the excess electricity, and what is the electricity need for the industry. Then, as final stage, there is a tab for visualizing the economic data. And in here, as you can see, relevant information are reported, going from the electricity cost, CO2 emission cost, the annual cash flows for the industries, and the capital expenditure indicators, as well with the payback period. Oh, sorry, I was here. Then going to another project involved in the Alliance, we have the EMBERS project, which aims at developing an open source tool to match the potential sources of the excess thermal energy with compatible users of heat and cold. Within the EMBERS project, they are developing a platform which is able to determine the cost and benefits related to the excess heat and cooling utilization routes for industries and end users. So the platform developed within the project as main goal is to contribute to the increased use of excess thermal energy. The platform per se has different, can provide different type of analysis, as is reported here. So on how to maximize, for instance, the environmental social benefits or the revenue maximization, on how to maximize the local access of heating and cooling use. Moreover, the platform is showing a very user-friendly interfaces with different analysis and the reports that can be easily downloaded by the end users as reports. And in the next slide, so in here we can have indeed an overview on how the platform it appears and it looks like. So also in here there are different tabs with different entries that must be inputted by the users. Moreover, the open source platform is composed by 5 modules that we can see here displayed. So one is the core functionalities module and the knowledge system, where it characterizes the quantity and quality of the excess heat. There is a knowledge system, including a number of databases. Then there is the GIS module, which is mapping least cost pathway to linking demand and supply nodes with a location defined by the user. The third module is the techno-economic module, which identifies the least cost combinations of technologies for using and conveying excess heating and cooling from sources to sinks. The fourth module is based on the markets module. So it is the valorization of the excess heat and simulates the current and future trends for the heating and cooling markets. Thus to allow the end user to choose the best market framework aligned with the user's economic, environmental, and social interests. And then finally, the business model module, where there is a valorization of the excess heat by evaluating various business models which can incorporate the excess heat. The open source platform with these 5 modules will be soon tested in 7 case studies in Europe. Then going to the last project that I'm presenting today. So this is the INCUBIS project. It is an energy symbiosis incubator, which aims at supporting the energy symbiosis for waste heating and cooling valorization in industrial parks. And it is also, so the incubator, it is designed to deliver services to assist the stakeholders in the development of energy symbiosis. As you can see here, as the timeline of the project, it is also in a mature phase, and this project will end in April 2023. The INCUBIS project is targeting different groups of stakeholders. In this picture, we have a quick overview. So it is targeting from ESCOs to park operators or owners, to NGOs, local governments, regional authorities, RTOs, and universities. And in this slide, we can see how all the targets audience can be motivated in implementing energy symbiosis, and each target group has different motivations. So energy symbiosis can benefit ESCOs and IPO, for instance, by expanding service portfolio and increasing profit. Then municipalities and IPOs can be motivated by minimizing the vacant land rate. IS facilitators can be motivated by providing and extending services down the synergy life cycle. Anchor tenants have interest by decreasing costs and increasing revenue. Municipalities can be motivated in, let's say, valorizing energy symbiosis because of environmental and social benefits, while IPOs, anchor tenants, and DESCOs because of CSR benefits. So the virtual platform developed within the INCUBIS project is delivered as online virtual platform and can be used by industrial parks, SMEs, or in general industries that are managing heat residues and who can be involved in heat exchange. the core functionality of the platform will be to create matchmaking between key actors of the heat symbiosis. And from this picture, you can see the layout of the platform, which is available on the INCUBIS website. So that would be my presentation about the different tools developed by the projects, some of the projects that are partners in the Alliance for ECEI. In here, you have the contacts. So if you want to know more about the Alliance, you can have a quick look at the website or follow us on the social media. And here you also have a contact email if you want to know further. And then again, it is important if you are interested in some of the projects that I presented, they all have, of course, website, and they also have social media accounts. So feel free to add them on social media and follow them to know more about the next stages of the project. And in here, you have my personal contact if you want to contact me. So thank you. That would be all from my side.
Thank you very much, Serena, for this comprehensive presentation. And I will take the floor right now. My name is Oksana Krasatsenko, and I was asked to introduce and moderate the panel debate in the framework of this event. I work for Euroheat Empower as Director of Knowledge Transfer. Euroheat Empower is the European association promoting sustainable district heating and cooling in Europe. And I find this event extremely interesting because, as we know, the EU produces more waste heat and cold that is needed to cover the demand of all our building stock. And we were previously involved in the landmark EU project called Heat Roadmap Europe that estimated that at least 25% of the heat demand can be covered by waste heat and cold in Europe. But we also see that this potential remains largely untapped. Therefore, the discussion of today's panel debate about how we can help industry and using the tools that were presented previously, and also to support the waste heat recovery value chain. So let's discuss drivers and barriers for the replication of the presented tools together with the project representatives. I would like to introduce Sergio Pinotti, CEO of Spinergy and member of Arasis project. So Sergio, hello. Thank you for switching on your camera. Our next panelist will be Nerea Nieto, researcher at the energy unit of Ikerlan and member of Bamboo project. Hello, Nerea. Nice to see you. Our next presenter will be Micha Jensterle, Senior Manager at Adelphi and Work Package Leader of Embers project. Hello, Micha.
Hello, trying to turn on my camera. Yes.
It works fine, thank you. And last but not least, we will have Emil Leshak, General Manager of ISNAP and Dissemination Leader of INCUBIS project.
Good morning.
Us on the
Good
panel.
morning, everybody. Thank you,
Hello,
Oksana.
Emil. Thank you very much. So just to start the discussion, I would like to get back to the results of the poll that we conducted at the beginning of the project. So let me share my screen and to show you what we have received as an input from our audience. Can you see my screen?
Yeah.
Fantastic. So here, exactly what I was saying, that the potential of waste heat recovery remains untapped. And this is due to, first of all, maybe lack of awareness about the nearby industries and services, what they produce, what type of energy they produce, because we can see that 42% are, barely aware of the neighboring industries, and it requires further investigations. I see that from the presented tools, they can be very useful in this respect. The second challenge is also a lack of awareness of the energy sources used by these industries. And here maybe the presented tools can also be useful. So to just start the discussion rolling, I would like to ask you, the panelists, how do these tools position in terms of addressing current challenges? Lack of awareness and also in terms of supporting energy efficiency improvements across the EU, and what role could they have for new or future policymaking? So let me just ask all of you if you could express your opinion on this in the order I presented you. So Sergio, what would you say?
Well, I would say that all the tools developed, as we've seen today, I present races, but all the other projects showed helpful tools that not only will help, according to me, to European to solve the European challenges you mentioned before, but to reach the target that we as a European Union, the environmental target we put before our current situation. The poll, the first one, confirmed what we felt based on our experience. There is this big lack of knowledge because the individual companies, most of them, they don't know the productive activities or services of their neighbors, and so let alone the production processes. If you don't know the production processes of your neighbor, you don't know if there is a waste heat to be recovered. So a tool like the CES assessment tool from RACES that we developed surely will help to solve this problem, to spread the knowledge and to improve awareness. Knowing what your neighbor is doing, how much energy is he wasting, it's not enough. Right? You have to move then on this information you acquired, and once you become aware, if you see you have some opportunities, you have to move on and move on quickly. And so the other tool, the legal support tool, kicks in at this time, so it provides a contractual basis for which to finalize the energy exchange agreement. But we've seen some other tools today that more or less provide you with a legal framework in order to move. And then you have to manage the exchange, the exchange agreement, exchange energy flow. So the energy management platform, which is the third one of RACES tools, helps you to manage in a painless mode the energy exchange going on. So I think all these tools are really needed, except most of them, the first one, the first part of the European project we've seen today. We need to know what's going on with our neighbor and what's still available in terms of waste energy with our neighbors. Because at the second point suggest us, most of our industries use fossil fuel or a combination of everything available. It means depends what you have. If you have hydropower, for sure you will use hydropower, but the renewable energy has the problem to be intermittent. We don't know if we got and when we got them, unless the solar photovoltaic energy, which is very few in terms of industrial process. So if we use fossil fuels, due to our current relation with Russia, but even before, we have to extract the maximum energy from a single unit of fossil fuels, and which means we have to minimize the waste. In order to minimize the waste, again, we need to know how much waste is around our company. So I think all the tools will be helpful and useful to challenge to reach the target we got as a European Union.
Thank you, Sergio. I would like to ask Nerea, in terms of the bamboo tools, what added value could they bring to the policymaking?
Okay, so in this case, the bamboo project is dealing with different waste heat recovery solutions, but they are thought to be used internally in the industry. So They are technologies thinking of different possibilities to reuse the waste heat within the industry. In our case, the tool we developed is based in the ORC technology. So the aim is reusing the available waste heat as electricity. Okay, so we are converting the waste heat to electricity. And the aim of the tool is to be used as a decision support system by energy managers, for example, in energy intensive industries, so that they can have an overview of the potential to convert their waste heat into electricity. So, as I said, the aim is to have a decision support system to have an overview of which could be the payback period, for example, of such an investment. But then, of course, if the industry is interested in going forward with the installation of such a system, they should contact the overseas technology manufacturer in order to have a detailed design of the solution. What we see is that even if the result of the pool says that we are not aware of the energy consumption or of the waste heat recovery potential of our neighboring industries, in most of the energy intensive industries, there is already the role of the energy manager. So at least this person should be aware of the waste heat streams available in the process. But it's possible that even if he knows the process, all the details about the process, he or she may not be aware of the technologies available to recover the waste heat. So I think that's the aim of the different tools that are being developed in the different projects, to make it easier for the energy managers in order to compare the different possibilities and then decide which is the best option for them and go into a further project to have a detailed analysis. But this way they have an overview of the different possibilities that are in the market, and this may help them to make a selection.
Understood. Thank you very much for these clarifications. And I would like to continue with Miha, and if you could just say a few words on the added value of the tools developed by Embers.
Sorry, what was again the exact question now?
Well, the question is, how can the tools developed in the framework of Embers position itself in terms of tackling the current energy crisis and supporting the increase of energy efficiency?
Okay, thank you. So with specific focus to Embers, I think it is like the other tools that we are seeing here today, a contribution to this ecosystem of knowledge, of tools, of methods, of good practices that is coming into existence now, because residual heat use is becoming more important as a topic. So I think it will provide an contribution to that. In terms of how exactly this impact will be, I think we will have to wait until it's finished and released into the wild, so to say, and see how much users like it, how much they pick it up. And in terms of policy, I think first, when all our tools will be used, they're first policy takers. So the policy is what it is, and the tools come in, and maybe this is my hope anyway. The tools show that what exactly is possible with residual heat use, and then maybe the policy follows. So they are in the second instance, a little bit later, they become policy makers. But again, we will have to wait and see, but this is for sure the hope. Yes.
I see. Thank you. And where is the project Embers finish?
It is finished on, I think, end of June, when if I'm not mistaken. 2023.
Okay, so we will. We still have some time to wait and see what comes out as a result. Thank you very much, Micha and Emil. I saw that you already answered the question about the added value of INCUBIS in terms of also taking into account the seasonality of the heat demand. So could you please elaborate on this, and what is the position of the INCUBIS tools in terms of supporting policy making?
Yes, of course, Oksana. And I have already the feedback of Sebastian that tools do not resolve physical problems. Completely agree as well that any virtual platform, any tools, whatever, which promising to have the deal, not solve the interaction between the seller and the buyer. Nevertheless, it facilitates the connection to make the quicker deal, providing inside of the virtual platform the tools which could analyze, optimize, and make the let's say use of the excess of the energy, because we are dealing in the INCUBIS with the industrial excess of the energy for the end users. We are trying to interview it and let's say make the analysis of as wider as possible stakeholders who need energy in different form, quality, and also quantity. So this for sure will not solve physical problems, but could mitigate this. We are doing this in the five regions located around the Europe, where there are different conditions, different political regulation, and to want to provide the universal tool. I would like to add that also the problem lies in the politics, in the local governance. There are quite many scientific research study provide the different models, different strategy, which I'm not going to provide here details, but they are, let's say, put on the desk what is important to be solved, and what the governments should support. Support in this meaning to facilitate, not to put the obstacles. So this we also are going to include in our virtual platform, which could gives the, let's say, better, or let's say reduce the physical problems between the buyer and the seller, between the demand and the supply. I hope that was quite clear. If not, I'm available for the further discussion, in particular telcos. Thank you.
Thank you for the explanation, Emil. We also received another additional question. Why do you assume that the energy managers are not aware of the available technologies? And yeah, Emil, you are ready to
Yes. I was trying to reply on the chat. I think we haven't said that energy managers are not aware. We said in the pool, I think Sebastian is referring to the pool, that neighbors are not aware about energy services. So in my opinion, since years in some regions, since decades, we transfer from fossil fuels to renewable energy sources. And since spring, we try to independency with the other countries which provide us the energy. So I think the pool not reflect in general the situation, at least in the Europe. We are fit recently with the information how to reduce use of the energy, how to use any renewable energy sources, how to insulate our homes and building in order to reduce as well. So at this moment, I think energy managers are completely aware about IT services, IT solutions, or technical solutions. Sorry, I should remove the IT. So.
Thank you, Emil. But I think it was mentioned by Nerea or during her answer.
Okay.
Yes. Yeah. Yes, I said that sometimes energy managers are aware, are always know the details of their process. They are aware of the waste heat sources in their process. But what I meant when I said that they are not always aware about the technologies that may help them to reuse those waste heat sources is that there is a lot of research. There are a lot of technologies that may be in low tier Earths. There are a lot of projects that are being developed in order to demonstrate different solutions for waste heat recovery, and they are not necessarily aware about all these solutions. So that was I meant. Maybe I'm not. I mean, maybe you have another opinion, but I think it's not easy for the energy managers to select the best option when dealing with a waste heat recovery solution. They may have an idea on what to do, but then they do not have the details on how to do it. And that's where the research centers or technology providers can support them. And like a first step, we consider that having a tool which may help them to have a quick overview of the different technologies and maybe have a comparison on the results that they could obtain with one or the other can help the energy managers.
Thank you, Nerea. I think that the benefits of your tools are very clear to me and to the audience. But let's think about the further exploitation of these tools. So how to scale them up from an EU project level to achieve their full deployment in Europe. And this is also one of my topics of interest, how to better exploit the results of EU projects. Maybe Miha, do you have any ideas on what are the actors to target as a priority, and who could provide some buy-in for the wider use of the tools?
For sure. I think part of the answer is that whoever is developing these tools right now, currently, we have to make sure that these tools are the best they can be, so that the users actually, when they see them, they pick them up, they try them on, and they have a lot of tools at disposal. Maybe they can try different ones. The hope is they find the one that suits their needs the best and actually use it, so that this tool can actually contribute to realizing the potentials of the residual heat. Now, but I think the bigger story are the potentials itself, right? Because you have to understand any sort of residual heat use project in the whole context. And this is, like Emil said, it's political. It also has to do with market, with regulations, with the administrative framework, with the stakeholders. So it's a very complex field. And if we just look at the market, I think one of the main reasons that residual heat use was not scaled up in the last 10 years is that until, let's say, the start of 2021, natural gas was really cheap and abundant. And like Mr. Zubero said before, the problem with residual heat is matching demand and supply. With natural gas, you don't have that. You have the perfect flexibility. You can cover every temperature level that you need in industry, and you can cover any demand profile that you might have. And residual heat could just not compete with natural gas. I think now that's changing. I think natural gas, even when this acute crisis now is over, I think it's going to be more expensive than it was before. So I am cautiously optimistic that this will be one driver for more use of residual heat. And I think The other side then is also the regulation. So the EU has been ratcheting up the environmental regulation. So CO2 through different models, different mechanisms is becoming more and more expensive. The companies are forced to be ever more ecological. I think what has become clear in the last 2 or 3 years is that the EU actually means it with climate neutrality 2050. I think a lot of companies that thought maybe we can sit this out. We're not going to be forced to be climate neutral by 2050. Now are actually thinking, okay, we are actually going to have to be climate neutral by 2050. So I think the drivers are bigger than what is happening in the project, but they are there. So I think now if we actually have good tools that help translate the potentials into actual projects, I think we can actually see residual heat use scale up in the next, let's say, 5 to 10 years. I'm hopeful.
Thank you, Miha. I fully agree with you. I think that the current energy crisis is actually the biggest opportunity for Europe to become climate neutral and to use all locally available resources. And waste heat is one of the biggest. Thank you. I would like to go to another level of discussion. So we discussed the EU policy supporting this. But what about local authorities? Are they supporting, promoting enough district heating around industrial areas or the development of industrial symbiosis? Maybe Emil, do you have an opinion on this? Are municipalities involved enough, and can they do better?
I think I have partly replied previously, but it's deeply depend on the municipalities, on the municipality which has the previously contact with the industry, which has the set up some infrastructure. So different factors related on the let's say willingness to support industry to let's say reduce the waste, technical regarding with the logistic for example, demand and supply. So as I said previously, there are several models, strategies which are public available, details everything which is needed to implement it. But what I discover, the local authorities are quite good in design and to provide any solutions, but when is the time for the implementation such solution, I mean that to provide the excess of the energy for the end users, any kind of the end users, not only district heating, but maybe to other, they step back. There is no clear answer. In some cases, could be that they step back because they don't have the, let's say, enough financial support to participate in it. Political, because there are different options between the, let's say, people who manage the energy and who is in the local government, etc., etc. So in general, depending on the, let's say, conditions, geopolitical conditions in the region or city, something like that.
Thank you, Emil. Does any other panelist have anything to contribute on the question of local authorities? If not, we will move on. I would like to discuss the topic of industrial energy symbiosis, and maybe ask Sergio, in your opinion, what are the limits and barriers today for industries that want to activate industrial energy symbiosis?
Well, according to me, most of the barriers there were before we started this European project are being tackled by all these tools. And I mean, the spread of the awareness and the knowledge among the companies, the legal constraints, and we can provide information about the technology as well as NERA advises us. The last main constraint is that the energy exchange, the waste energy exchange or the waste recovery is a high capital intensive investment. At time zero, you have really to throw in a lot of money. It's a situation of it's a win-win situation on both of the parties involved. But in the beginning, you really have to build in the infrastructure to exchange the energy. This going back to Emil, this according to me, it's something only the municipalities can do. Someone above the companies and with the help of the fund from New Generation EU, from our plan after the youth, we now have the opportunity to have some funds, some money to build up this network which are not electrical but are thermal, the district heating network or something in order to help companies in the same little area to provide infrastructure for this heat exchange. Among these, it's not only the lack of knowledge among the policymakers, but even at least in Italy, their short time horizon, because the payback time of a district heating network is longer than the time frame of the policymakers have in mind, because they change every 4 years here in Italy. So this is an issue I don't know how to solve. About letting them know that we need, as companies, as energy manager, something to be connected. I guess it's a law enforcement tool that just have to come in. We've seen in Italy, if you live in a big city, if you're a company in a big city, you have to write down every year the commute plan of your employees, and you have to share this commute plan of your employees to the mobility area manager of your ecoregion. In order you have the knowledge to say there's a lot of people moving from A to B, maybe I can build a train there, and so they will not use the private cars. We can, or with this tool, we can summarize this plan to our policymakers in order to let them know where we need an energy exchange infrastructure. Who's going to pay for it is the other big issue I still see. But with the Next Generation EU, we can tackle it as long as our policymakers look a little farther than their time for servicing.
Date.
Okay.
So you are looking more at the EU funding rather than alternative sources.
Oksana, if I may have one comment to my, let's say, to my feedback, and also to Sergio. So local governments should be kind of the knowledge broker to provide the information about possibly financial tools, excess of the energy, demand for it, try to organize matchmaking. So this last comment from my side.
Thank you. And Miha had a comment as well.
Yeah, since we've returned to the local authorities, and because Sergio mentioned that Italian companies have to basically show how their employees will come to work. Something similar has been discussed anyway for German communities. Basically, that they would have to do a local heating planning with maybe horizon of the next 10 or 20 years. Because often residual heat sharing projects fail because the local authorities are not in the position to manage the infrastructure that would be required for it. At least during the current legislative period in Germany, it doesn't look like this will happen, but I assume at some point it will have to happen. It's been discussed, it's been demanded by think tanks, by NGOs. I think the political will is not there at the moment, but I can imagine
I'll
that
tell
at
you
some point.
more. It's not only discussed in Germany, but it's discussed at the European level with the revised Energy Efficiency Directive. And the initial proposal was that all municipalities having a total population higher than 50,000 inhabitants will do this mandatory heat planning. Now this threshold is even being lowered. So it's very likely that this is going to be an obligation for municipalities with at least 35,000 inhabitants. So we very much look forward to this legislative obligation for local authorities to do heat planning and to then implement waste heat recovery projects. So time is running, and I still wanted to ask something, Nerea, about the industries. So how could be promoted the link between industries in order to develop industrial symbiosis?
Okay, well, I think that most of the key points have already been commented previously, but I think that one important challenge is there needs to be a flow of information in order to enhance the stakeholder awareness of the benefits of the industrial symbiosis collaborations. Normally, and we have also seen in the results of the poll, there is a lack of knowledge of the subproducts or of the resources that are required in nearby industries, and almost in most cases, there is not a tradition of collaboration between industries. And normally they are not willing to share information between industrial actors because normally they are competing to each other. So this finally results in a limited sharing of resources. And another point is also that industries often find that everything that is out of the business as usual approach is a distraction for the process. They are focused on productivity and on production issues, and normally, well, this is now changing, but sustainability or decarbonization is not the focus of the industry managers. So I think new mindsets are required, willing to change the existing practices. I think we all have commented also that we need like an external party or a third party, which needs to be seen as a neutral player in order to motivate and facilitate the collaboration in industrial symbiosis clusters. This role may be taken by public authorities. They should have this role, and they should have a leadership role in order to build trust among industries, business development organizations, and also research institutes. They should act as the coordinating body. I think we shouldn't expect industry managers to take this role of analyzing the viability for a collaboration with another industry, but there should be an external body, a public authority, which makes this work. And in this regard, there should be external players and experts which can maybe map the areas with strengths and development potential for industrial symbiosis, and also who validate the viability of this type of projects, and then share the results with the involved stakeholders. Even if we may not expect an active role from the industry. I think it could be recommendable if there is a team or a figure in the industry which is responsible to explore and drive these synergistic opportunities. And I would also recommend to industries maybe starting with small initiatives and experiments first, and not going to maybe a large scale project from the beginning. And this way they can gradually build the experience required for such projects, the capability, the capacity, and also the confidence required. And well, as Sergio, I think it was Sergio who has commented that the economic aspect is really a challenge. Industries won't embark in a project if they don't have the trust that they are having future savings in terms of materials and related costs. So I think financial incentives are a must in order to promote the link between industries. And maybe one last point, something we see as a research center trying to support industries in their path to decarbonization is that it's always easier to engage an industry in a big investment when there is somebody else who has already done something similar and has obtained beneficial results. So I think the dissemination of best practices related to industrial symbiosis is also very important to encourage the industry to participate in such projects.
Thank you very much. I fully agree with you, and I would also like to thank the Alliance for ECEI for bringing these projects together, for showcasing these tools and also best practices at a similar kind of events. So this webinar is also organized as part of the EU Sustainable Energy Week. So I hope that all the attendees are now enlightened and have a better picture of what's available, what has been developed by the European projects, and some of them will test your tools and implement them in their industrial strategies. I would like to hand the floor to Fabrizio Garasi to wrap up these discussions and maybe to say some final words.
Of
Thank
course,
you. Thank you for your input.
Thank you, Oksana. Thank you all. So we received several questions. Due to the short time, I selected just 2 of them, maybe 3 if we have time. One is for the project INCUBIS, the other one is for CORALIS, and the third one is for Mr. Azier Zubero. I will start with the question for Azier. Sebastian asked, for use in district heating, the obvious problem is the seasonality of the demand. How do you tackle this? So I please Mr. Azier to reply to this question.
Yeah, well, the main point is that we have more energy available than what is needed in the district heating, so there is no problem with the seasonality demand. So we have energy enough to cover their needs.
Thank you, Azier. I will move on to the second one. Eric Lecomte asked to CORALIS project. So I would please one partner from CORALIS to reply to this question. Heat storage. At what temperature do you store heat? And what temperature you recover heat? For how long do you store heat, and what is the technology used? So I would ask to somebody from CORALIS project to briefly reply to this wide question.
Yeah, well, from our part in CNR, I don't have all the information about the technology because this thermal storage technology is from our partner Energy Nest. But regarding for how long we store the energy, it is not a matter of time. It's just a backup. So it's a kind of hours or one day. Of course, I am sure that maybe it's possible to keep the energy for longer time, but that's not the point in our project. It's like a backup, and in hours we use the energy. Regarding the temperatures, I really don't know what's the temperature inside the thermal battery, but we send the waste heat in around 300-400 degrees, and the thermal losses are very, very low in the thermal battery, but I really don't know how much.
Thank you, Azir. So we have time for the last question for INCUBIS project. So I think that Emil will be the best person to reply to this question. I ask you to give your reply in 1 minute.
Yeah.
Yes, they ask you what activities are still needed to encourage companies to join Energy Symbiosis project.
Thank you, Fabrizio. In my opinion, the company managers are a very pragmatic person who need to know what are the financial incentive, but also they are interested to join the project when they reduce the waste which they store or have to transfer to other companies. So there are shortly two issues. Financial intensive and reduce of the waste which they create on the production line or the production of energy. Thank you.
Thank you very much, Emil. So we are done. We are in time. I would like to thank you all the participants, speaker, and of course the moderator for this interesting conference that I think that made us understand even more the potential of industrial symbiosis and especially how the technology answers such as the various tools that have been presented by Alliance project, how these technological answers are a great help for industries to achieve the energy transition deal that we all need. And I think especially in this time of energy crisis that we are living today. So many thanks again, all, for your interesting insight that you give us today. And I wish you a really nice day. Thank you.
Thank you for the organization. All the best.
Thank you. See you. Bye.
Thank you.
Thank you
Bye-bye.
very
Bye.
much. Bye-bye. Thank you
Thank
for
you, everybody,
joining.
for sharing.
Thank you for the
Bye-bye.
panelists and the moderator. Bye-bye.
Goodbye.